Hi everyone, I'm Shreya. Welcome to week 8 problem solving session. And today I'll be focusing on problems and their solutions based on the concepts which were discussed in week 8 lectures. So, without any further delay, I'm going to get started. Hello? Hello, Dr. Gaurav. Can you hear me? Okay. So, welcome back to week 8 problem solving session. My name is Shreya. Sorry. Can you see me and hear me? I hope I'm audible.
You are audible.
Okay, thank you, sir. So, welcome back to week 8 problem solving session. Sir, will you please mute your microphone? That will be a lot helpful. All right. So, I hope this screen is visible to you. So today I'm going to discuss a few problems based on the concepts which were discussed during week 8 lectures.
Ma'am, I want to ask some questions related to June number 8. Can you help me?
Which one?
Question number in assignment, like third question, action follow distribution exponential with the lambda. Then what is the way how to check it is convergence in probability or distribution? जैसे सर्वे वहाँ पे कुछ एग्जाम्पल तो दिए थे मैं और यहाँ पे जैसे मैंने थर्ड एग्जाम्पल में बोला कि एक्शन फॉलोज एक्सपोनेंशियल डिस्ट्रीब्यूशन then what is the way to check the how it converges in probability?
So for convergence in probability, you have to find out that limit. And which question are you referring to?
Ma'am, I am referring question number 3 of assignment 8.
Oh, assignment 8. When is the last date to submit?
We have to submit by 18th, 20th September.
1 second, I'll just. Okay, so the due date is 20th September, right? So I'm really sorry, but I'm not allowed to explain or solve assignment questions before their due date.
Okay. Can you
So,
just guide me if we have a given distribution and just give another example? If how to check the distribution, if it is versus probability and distribution, how can we check if we know distribution? As sir has not explained any example like given by any distribution.
okay, so today I'll be solving a few problems which will cover this probability in convergence in probability, convergence in distribution, convergence in absolute sense, and Adath order moment term. So if you could just look at how I hope you would get some idea as to how to solve such kind of questions. So
Actually, sir hasn't given good examples. He just gave an example of action is equal to one man like that. He hasn't given an example related to any distribution. That's why I'm getting problem in this time. Previous assignments I have solved very well by the structure problem here.
Okay, so here, which question are you facing problem?
Almost every question which is related with the convergence of distribution probability other it is also related to the movement convergence. इतने क्वेश्चन से प्रॉब्लम आ रहा है जो सीआईटी वाले क्वेश्चन पे हो रहे हैं सारे.
Your voice is breaking, sir. Can you please repeat what you said?
हेलो.
Yes.
मैं समझ नहीं आया क्या बोला आपने. I'm not getting it clearly.
Your voice is breaking. I couldn't hear whatever you said. I mean, I could get bits and parts of it, but not entirely. So, if you could
Yes,
repeat.
yes. Please give one or two example with the distribution when the distribution is given and how to check the convergence.
Okay, so when you have a distribution, let's say you have that x1, x2, xn follows some certain distribution, and you have to show convergence in distribution. So the way about how you should do it, you should write down the CDF of these individual, let's say xn. For xn, you write the CDF. Find out as n tends to infinity, where does that CDF go? Whichever CDF it goes to in limiting sense, what is the distribution of that random variable? So suppose you have, say, some distribution function, okay, fn. So you write it in terms of n. Find out when limit n tends to infinity, where does fnx go to? If fx goes to a certain distribution which is also like known to you, then it converges to that distribution. Alright?
Suppose we have any distribution related to uniform distribution
Okay.
in any interval 0 to 8. Then tell how can we check its convergence in RF movement?
Convergence in distribution.
No, convergence in the RF movement sense.
Okay, so for this thing,
Suppose I have a distribution with the uniform distribution over interval 0 to 8. Then please tell how I can check its convergence by RF movement.
okay, so you have the sequence of random variables. So from there you find out the sequence of CDFs or the sequence of PDFs, whichever is convenient to you. Okay, so from that sequence of
How can I find the sequence of PDFs as a uniform distribution? The PDF function will remain constant. It will be 1 over A. So it will be always 1 over A for all variables. Sequence.
then it will be that it will converge in distribution to that only.
But if I have to check its RF movement convergence, then how can I check it?
So you get that limiting distribution fnx, you get either the PDF or the CDF, then you do expectation of x to the power r. Then you
मैं आपसे एक बात पूछना चाहता हूँ कि जैसे आप कहते हो कि जो xn approaches to x है in limitation in by distribution, how can we get whether what is the value of x? हमें कैसे पता लगा कि x क्या होगा इसमें?
so
We can make sequence of the xn, but how can we came to know कि what will be the convergence that is x?
so that's what, no, so if you have the CDF or the, I mean, especially I'm talking about convergence in distribution. See, CDF is unique. So for exponential, it will be 1 minus e to the power minus x only for every x greater than equal to 0. If you get something similar to that form, then you can say that this converges to exponential with these parameters. Okay, so for especially about distributional convergence, find out the CDF. When n tends to infinity, it will go to some CDF f. You see that form of that CDF and the parameters involved. Okay, so if it matches, then well and good.
Suppose I have a sequence minus 1 by n or 1 upon n with the same probability 1 by 2, 1 by 2.
Which
Hello, are you listening?
Yeah, I'm listening. You say.
Suppose I have a sequence minus 1 upon n or either 1 upon n, either positive or negative, with the same probability 1 by 2, then how can I check if the converges in the case of distribution?
You find out the I mean FNX, say CDF.
वो कैसे कंपेयर करेंगे इस केस में?
What is that you are telling? Something with some probability, something with some other probability. So go by definition first. CDF means what? Probability xn less than equal to x.
Okay.
So this one is a, I mean, it's like a 0101 case. So PDF will also be something like this. So CDF, this is a discrete thing, minus something plus something. So
Okay.
you have the probabilities there, half and half. Try to write down the CDF, probability xn less than equal to x. Then you
Okay.
see where it goes as n tends to infinity.
Okay. If I have to check if convergence is almost sure, then what to do?
So I would urge you to hold on. I am starting this session where I'm going to tell you how you should try to tackle these problems. You start by the definition and then probably you will reach it there.
Okay, okay, thank you.
Okay. So here, as I
Ma'am,
have
actually, now I'm just going to leave this meeting as I have to go some other.
okay,
Okay, so thank you very much for your interacting with me.
okay, thank you.
Thank you.
Uh,
Hi, ma'am.
Hi,
Ma'am, could you please help in understanding the question number 2 and 4 of week 7?
week 7. Okay, 1 second.
Sure.
Week 7, I have to. Question
Question number 2 and 4.
2 and 4. Okay. So a person, can you see the screen? I'll stop sharing.
Gaurav, can you please mute? Hello?
I think I'll mute him. Yes. All right. So, question number 2 you are saying, right? Hello?
Yes.
Okay.
Yes.
So a person is shown n pictures of babies and asked whom they belong. Let X be the corresponding to well-known people and then asked whom they belong. Alright? Let X be the random variable representing number of correct answers. Alright, find expectation of X and variance of X. Yes. So where is your doubt?
I'm not getting the answer. I am EX is equal to 1 and variance 1. I understand that is it a binomial distribution, right?
Yes, it is a binomial distribution. Number of correct out of n uh, answers. So, uh,
So the probability is like half, right?
probability of 1 second. Find expectation. Person is shown n picture of babies, all corresponding to well-known people, and asked whom they belong. Okay, the probability is not half. The probability is 1 by n.
Okay, okay. All right.
because it belongs to, I mean, it could belong to any of those n well-known people, right?
Got it. Got it. Got it. Got it right
So
now.
it's np 1 by n, that is 1, expectation is
Yes.
1, and
Mm.
variance of x is npq.
Yes.
So that is also n into 1 by n into
1 minus
1
1 by
minus 1 by n. So how much will that come to?
minus 1 into n. Which shows that n into n minus 1 divided by n squared.
Hmm. So these numbers are not coming then. Corresponding, let x be the number representing mm, okay, which one else do you have a problem in?
With fourth question.
Okay, let xy be a two-dimensional random vector. Covariance between x and y is okay.
1 by 36 is the answer, but I'm not able to derive it. Could you please help me on that?
Yeah, okay, I'll help you. 1 second. So here we have f of xy equal to 2 if 0 less than x less than y, and when y is less to 1, 0 otherwise. And we have to find out covariance of x and y equals to expectation of xy minus expectation of x and expectation of y. So you found out these two?
Yes, I found out these two.
Okay. So
Uh,
expectation of x will be, so first you have to find out the marginal of x.
yes,
Okay, so marginal of x, how we will get fx equals to over y,
yes.
we are going to take, so 0 to 1, this thing.
Is equal to
Okay, so x range will be 0 less than x less than 1 second.
y. So yeah,
So this will be 2, sorry, no, 1 second.
yeah.
uh, Covariance xy expectation of, no, 1 second.
The marginal of y is like 0 to 1, 2 dy, right?
This
Integral of 2 dy,
marginal of y
0 to 1 is
is,
the marginal of
marginal of y is 0 to y.
Hello, Mr. Gaurav, can you please mute?
This is the marginal of y, 0 less than y less than 1. Okay,
Yeah, so the marginal of f of x should be like integral 0 to 1, 2 dy, right?
yes, it should be 2 dy, sorry, dx, and x can range from 0 to y.
Yes.
But y can range from 0 to 1.
0 to 1.
this is the range. X can range from 0 to y. So this is the marginal of y. Marginal of x is, we have to take the range of y. So y can range from 0 to 1. So this is
Yes.
0. This is 2. 0 less than okay. So these are the marginals, let's say. And
So, could you the marginals of f of equal to 2 and the marginal of y?
expectation, so this thing we have to find out expectation of xy. It means xy fxy dx dy. So this will be 2xy dx. X will range from 0 to y and y will range from 0 to y. Okay, so this will be 2y 0 to 1.
Ma'am, is there any way I can see your calculation board
Oh, it's not visible
to make out what you are saying?
okay, fine. Really sorry.
No.
No. Here.
Okay, thank you.
Okay, expectation of xy. This will be,
Could you please show what? Okay.
this is the thing, right? Now x will range from 0 to y and y can range from 0 to 1. So this will be how much? 0 to 1 2y.
Yes.
This will be y square by 2, right? dy. So this will be
Okay.
0 to 1 y cube dy, y to the power 4 by 4, 0 1. This is 1 by 4. So expectation of xy is 1 by 4.
Okay.
Okay,
Yes.
this one you got?
Yes.
Okay, and
I got expectation of.
so now we have to find out expectation of y. That is y into fy dy. So now y will range from 0 to 1 y. Fy is how much? Fy is dx. X ranges from 0 to y 2. Okay, so this will be 0
Yes.
to 1 y 2y dy. 0 to 1 2y square dy. This is 2y cube by 3, 2 by 3. This is okay. And expectation of x will be x into fx dx. X can range from 0 to 1, right?
X 0 to y, right? So how?
But y can range from 0 to 1, right?
Okay.
So
Yes.
x in total can range from 0 to 1. So this
Okay.
will be
Okay,
0 to
ma'am.
1 x. Now this is fxy, that is 2 dy, and y can range from x to 1. So it
Okay,
is
how can
like
we take
this.
that?
This
Okay,
will
okay,
we
okay.
can derive, right?
Okay. Got it.
Okay, so then we'll have 0 to 1 x. This will be 2 into 1 minus x dx. So 0 to 1 2x minus 2x square dx will be 2x square by 2 minus 2x cube by 3. 0 to 1 will be 1 minus 2 by 3, that is 1 by 3. So covariance will be 1/4 minus 2 by 3 into 1 by 3. 1/4 9, 2 by 3, so it will be 36. 9 minus 8, that is 1 by 36.
Okay, I made that mistake from
Ah.
taking the limits of y. That's what.
So this one will be 1, marginal of x is, x can range from 0 to 1 and y can range from x to 1. Okay, so just forget this slide. This is incorrect. This is fine, right?
Yeah, this is fine.
So the range is this.
Okay, got it.
All right.
Got
So
it.
this one is solved. Then the other one was this thing. A person is shown n pictures of babies, all corresponding to well-known people, then asked to whom they belong. Let x be the random variable representing the number of correct answers. Okay. Find expectation of x and variance of x. One person is shown n pictures, number of correct answers. Okay, so let's try to work this out. X is number of correct answers. So x follows binomial n and picture of n babies, correct or not. Let's say this is the success probability. Alright, now n pictures all corresponding to well-known people. So n, so let's say child 1 belongs to that with 1 by n probability and the others with 1 minus n minus 1, 1 minus 1 by n probability. So correctly identifying success probability is 1 by n.
Okay.
So then expectation of x is np, n into 1 by n, that is 1. Variance of x is npq. Here there is a problem. Why is it then not binomial? All corresponding to whom they belong. Okay, 1 second. They then asked whom they belong. Number of correct answer probability. Answers correctly is half. Answers incorrectly is half. To whom they belong, correct answer probability is it belongs to 1 out of the n. Yeah, I think there's a problem with this variance part.
Okay.
Okay, so either that or there's some other way. So right now I cannot think of anything. I'll get back to you
Is
on
there
this.
any, okay, but is it any other distribution it belongs to?
That's what I'm thinking. Because the
That
number of correct answers out of n is binomial. That part I'm sure. But if this has to be formulated here, this a person is shown n pictures corresponding whom they belong. So n person belonging to n different people. This thing I'm not so sure about. Uh, do you get solutions of these questions?
No, I was not able to make it out. That's what.
Okay, no, I am just asking because till week 3 solutions were posted, but week 5, 6 there are no solutions so far. Alright, this is something new.
Yeah, the solutions will be posted only like correct answer, accepted answer. So if we have got any doubt, we wanted to come to
Oh,
this
okay,
class.
okay, okay, fine. No, but till week 3 I can see solutions posted. Can you
Yeah.
see? So
Yes, yes.
maybe they've not updated. You give me some time. I will look
Okay.
into this and maybe get back to you next weekend. If
Yeah,
that's
sure,
okay
sure,
for you.
sure, sure.
All right. This one you understood, right?
I understood that
Okay.
one that I was not understanding the concept. That's what.
Okay,
Yeah,
okay.
I got that.
All right. Any other doubt?
No, I have no doubt for the week 7. So week 8, the mode of convergence, I am not able to understand the concept. Is that
Yeah.
possible for you to
Yes,
tell
yes.
something about that?
Yes, yes. So I will start with a few problems which will hopefully help you tackle week 8 like sorry problems. So
Sure.
you have learnt about the modes of convergence, right? Distribution, probability, absolute sure, and the rth order.
Yes.
Okay. So distribution convergence is what xn will converge to x if their CDFs converge to their CDF of this random variable x. Okay.
All right.
Next is the convergence in probability. So convergence in probability will happen if we can find out that this probability xn minus x greater than epsilon, it goes to 0 in limiting sense for all epsilon greater than 0. For convergence in rth order moment, expectation of xn minus x to the power r should go to 0, and absolute sure is that the random variable itself should go in absolute sense to uh, this xn should in absolute sense means the limit of this random variable should be x, and that should be that probability should be equal to 1. So this was the hierarchy that was followed. If rth order moment converges, then the first order moment also converges. Then we can say it converges in probability. If it converges in probability, then it will automatically converge in distribution. And also if it is absolutely if it is um, absolute sure convergence, then it will go converge in probability and then it will converge in distribution. Also we heard of the law of large numbers. Then of if we have a sequence of IID random variables where mean and variance exists, then this thing converges in probability the to mu. That is these sequence of random variable converges in probability to the mean of this IID sequence.
How we calculate the convergence? Is
Yeah,
there any?
I'll show you how to do it. So this was the Bernoulli's law of large numbers. The difference between weak law and strong law is that the strong law says it converges in absolute sense, and weak law says it converges in uh, probability. And also we learnt about central limit theorem. So I'll just start with this problem. Okay. Here we have a sequence of random variables. We have defined yn as the minimum of x1 to xn. Then which of these are correct options? Alright. So first thing is, let us check for this one. Does yn tends in distribution to 0? Now fnx, let this be the CDF of xn. Okay. So
Okay.
xn follows what? It follows uniform 0 1. So probability, so CDF of a uniform 0 1 is what? 0 if x less than 0. From 0 to 1 it is x, and beyond 1 it is 1. This part you remember, hopefully.
Yes.
Okay.
Mm.
So this will be 0 if x is less than 0, x if 0 less than equal to x less than equal to 1, and 1 if x is greater than equal to 1. Alright, now we have to find out the CDF of yn. So let us find CDF of yn, which is minimum of x1, x2, xn. So CDF of yn is probability yn less than equal to y. This one we can write as 1 minus probability yn greater than equal to y. Okay, or I'll write greater than y. Alright, so the minimum is greater than, let's say this is minimum. So this minimum is greater than y. It could be x3, it could be x4, x1 could lie here. So if the minimum is greater than y, it means all the random variables are greater than y. So that would be probability x1 greater than y, x2 greater than y, xn greater than y. Is this clear?
Yes.
Okay. So now this one they have given is a sequence of IID random variables, independent and identical. So this will be 1 minus probability x1 greater than y into probability x2 greater than y into probability xn greater than y, since independent. So this could be 1 minus probability x1 greater than y to the power n, since identical.
Okay.
Okay, this one is 1 minus probability of x1 less than equal to y to the power n. This is what 1 minus fx whole to the power n fx1. Okay, so that is fx1 is how much? This x thingy. So this one we'll write it as equal to 1 minus x, sorry, we will write it as greater than y na, so this will be f1y. So this will be 1 minus 1 by y. One second. Okay, so f of y and y is 1 minus 1 by y whole to the power n. Okay, now yn, this y is minimum of some variables. Each of these are 0, range is 0 to 1. Okay, so the whichever is the minimum, that range will also be 0 to 1. So do you agree with this?
Yeah, got it.
Got it. Okay, so then what we have is f of yn y is 1 minus 1 by y, where 0 less than equal to y less than equal to 1. So 1 minus y will also be will lie between 0 and 1.
Yes.
Okay, now so this to the power n, so this thing entirely, this is a fraction
Yes.
which is less than 1. So
Yes.
as n tends to infinity, this fraction will go towards 0, fraction to the power n, as n tends to infinity.
Okay.
Because you see half, let's say 1 by 2 to the power n, half, 1/4, then 1/8, 1 by 64, so on, so on, so on, so on. It will become very, 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 very close to 0. Similarly, 1
Okay.
by 3 to the power n, 1 by 4 to the power n, all will go to 0 as n tends to infinity, because these are fractions less than 1.
Got it.
Okay, so then this entire part, so then we can write it equals to 1 minus 1 by y to the power n, 0 less than equal to 1 less than 1. So this will tend to 1 as n tends to infinity for any y between 0 to 1.
Okay.
So then this one we can say that f of y and y tends to fy, where fy equals to 0 if y is less than equal to 0, and 1 if y is greater than 0.
Okay. Got it.
So then what it is showing, so this essentially shows that yn goes to yn is converging in distribution to a random variable which is degenerate at 0. This is the CDF of a degenerate distribution
Okay.
at 0. So how the CDF looks like? CDF, let's say this is y. Till 0 we have nothing, fx value is 0, and directly at 1, this is 0, till it touches 0, it is 0. Once it crosses 0, it jumps to 1. So this is like a degenerate distribution at 0.
Okay.
Okay, so this one, or this is whatever, anything. You got it right? So when y is
Yeah.
0, f and y will be 1.
Okay.
When y is 1, f and 1 will be, so when y is, so we'll write this way, when y is 0, f y n y equals to 1, which will go 10 to 1 as n goes to infinity. So that's why here we'll have greater than equal to sign. Okay, and
Okay.
when y is 1, then f y and y is will also go to 1. Sorry, when y is 0, f y n will go to 0, because 1 minus 0, it will be 1, 1 minus 1 is 0. So the less than equal to sign will be here, and greater than 0 it will be 1.
Okay.
Alright, so this was it, therefore it converges in distribution. This part we have cleared. Now we have to see, does it converge in probability? So yn converges in probability to 0. This thing we are going to check. Okay, so f y and y was how much? When y is less than 0, it is 0, because minimum will, this is minimum, right? So
Yes, yes.
all 0 to 1, less than 0, it will not happen. Okay, y greater than 1,
It's 1.
1. Okay, from 0 to 1 we had it calculated, 1 by y whole to the power n. Okay, so now we have to show probability yn, it is going to 0, right? So this will be yn greater than equal to epsilon, limit n tends to infinity, this entire thing will be equal to 0. Okay, now since yn is lying between 0 and 1, this is equivalent to show limit n tends to infinity, probability yn greater than equal to epsilon equal to 0. Alright, so now we have to find out probability yn greater than equal to 0. So this one implies limit n tends to infinity, probability this one greater than equal to epsilon, we have to show that this equal to 0. So we'll start from here. This is equal to limit n tends to infinity 1 minus probability yn less than equal to epsilon. Okay, so this will be 1 minus yn less than equal to epsilon is how much? We have written the CDF. So instead of y, we'll write epsilon. So this is 1 minus epsilon whole to the power n. This is what? 1 minus epsilon whole to the power n. Okay.
Okay.
So this one equal to 0 when epsilon is belonging to 0 to 1.
How can it be?
Because epsilon is, if it is not a fraction, then this will not converge to 0.
Okay.
It has to be a fraction, no? Though then only this 1 by to the power n thing will go to 0.
Okay.
Okay, so for all epsilon from not excluding 0, epsilon
Okay.
should not be 0. If it is 0, then it will go to 1.
Got it.
So this will converge in probability for epsilon 0 to 1. Alright, the next one was what? Yn, whether it converges in absolute rth order moment. Okay, so we have f y and y as 0 if y less than 0, 1 if y greater than 1, and 1 minus y to the power n if it is between this. So from here we can write down the PDF. So f of y and y is how much? D dy of f of y and y. This will be how much? This will be minus n 1 minus y to the power n minus 1 by minus 1, n 1 minus y to the power n minus 1. Okay, so we can write this as, so then expectation of yn whole to the power r will be how much? Will be 0 to 1 n 1 minus y to the power n minus 1, this was there, into y to the power r.
Okay.
Actually, it will be mod y to the power r dy, but here y is positive. So it's the same thing as 0 to 1 n 1 minus y to the power n minus 1 y to the power r dy. Okay, so this will be 0 to 1 y to the power r 1 minus y to the power n minus 1 dy and n. If you solve this, this will come out to be 1 by n plus 1 if you do by parts.
Okay.
Okay, so what you have to do is you have to take this thing n 0 to 1, what was this, y to the power r 1 minus y to the power n minus 1 dy. So this is u, this is v. So u integration v d minus d du u integration v dv. This one if you solve, then this will come out to be 1 by n plus 1. Okay, so then what do we have? We have that limit n tends to infinity yn to the power r equals to limit n tends to infinity 1 by n plus 1. So this will be also 0. So this means that yn converges in rth order moment to 0.
Okay.
Then what we have is the fourth one, that is whether they converge in absolute sense or not. So if we can prove that this n equal to 1 to infinity probability yn greater than epsilon equals it exists, then we can show that yn will tend in absolute form to absolutely converge to 0. Okay, so this follows from the theory of convergence. If a series exists, then limit of each of the terms should be 0.
Limit of each of the
Constituent terms.
Okay.
Okay, so if we can show this thing that this exists, then yn will sure then the absolute sure convergence will hold. Okay, so here we'll do this summation probability yn greater than epsilon n equal to 1 to infinity. Is safe to write summation n equal to 1 to infinity probability yn greater than epsilon. This will be summation n equal to 1 to infinity 1 minus epsilon to the power n 1 minus, or yn was what? I'll write it here again. F of y was 0 when it was less than 0, 1 it was greater than 1, and 1 minus epsilon to the power n between 0 to 1. So greater than this means 1 minus epsilon whole to the power n. Okay, so this is an infinite GP. So this will be 1 minus epsilon into 1 by 1 minus epsilon. This is 1 minus epsilon by epsilon. So this is equal to, this is some finite value, that it's not going to infinite. This exists because it's some finite value. Okay, so then we have proved this thing. So it means that yn converges absolute shared sense to 0. This comes from the series convergence law. I'll tell you the exact law. One second, can you see my screen?
Yes.
So this one is, I don't think there's a law to it, but series review, 1 second. So if the series converges, then sequence converges to 0.
Actually, what is the application of this convergence of models?
Convergence of models, the application, what I believe is, if it converges in this thing in absolute sure form, then we can say it converges in distribution as well. Then if we have a large number of, so if you remember this hierarchy, okay, if it converges in distribution, then it becomes easier to if you have a large sequence of random variables, instead of drawing samples from these, if I can draw, if they converge to a much simpler and more applicable, usually prevalent random variable, instead of sampling from here, we can always sample from these known distributions, with good properties. So that makes our calculations and the further downstream events very easy.
In which industries this kind of convergence of models is being used?
Convergence of models, I think in drawing samples you can make use of it, or there are several industries I'm not so sure about, but maybe in some cases, like this CLT, central limit theorem, that also is like converges, it's similar to convergence in distribution.
Okay.
So industries, I don't have a very clear cut answer right now, but there are, especially while drawing samples, if you have a large sequence, instead of drawing from such complicated thingies, you can just drawing samples from that, the distribution to which it converges. If the n is large, then it becomes easier. Also for testing in case of approximations, quality control, in quality control industry, if you have a huge uh, pack or those kind of things, there these approximations are a lot of there's a lot of applicability.
Okay.
All right, so I'll move on to the next one. Okay, so here we have a sequence of random variable. We have to show that it converges in distribution to exponential random variable. Okay. So how should we do this? So here xn has geometric lambda by n. Okay, so we have defined a new sequence yn equal to 1 by n xn, and we have to show that yn converges in distribution to exponential this thing. Okay, so geometric CDF. Probability xn less than equal to x. Okay, this means what? This means summation 2x y from 0 to x p q to the power x, sorry, y. Is it okay?
Okay. Is it based on any? Sorry. Is it based on any formula that
Yeah,
P and
geometric. So let's say y follows some geometric p. So then if w is q to the power x minus 1 p for, sorry, w equal to 1 2 3 and so on. This is the PDF.
Okay.
Okay, so CDF is probability capital W less than equal to W small w, which is what? P w to the power y, q w to the power y minus 1, or let's say if we put w equal to 1, so this will be p plus qp plus qp square plus so on plus qp to the power w minus 1, right? This will be the CDF.
Okay.
So similarly here we would have y equal to 1 to x p q to the power y minus 1. Alright,
Yes.
so this one, instead of p we'll write lambda, or let us write p only. P q will write 1 minus p. So this is y equal to 1 to x 1 minus p to the power y minus 1 into p. Okay, so this one we can write is equal to some p summation y equal to 1 to x 1 minus p to the power y minus 1. We'll expand p into 1 plus 1 minus p plus 1 minus p square plus 1 minus p to the power x minus 1. So this is an AP series, or sorry, a GP series, finite GP.
Okay.
Okay, so this will be p into 1 minus p whole to the power x, this one plus 1, by 1 minus p, sum of finite GP. Okay, so p and p will cancel, so we would have 1 minus p whole to the power x. This is okay. So here what they have said, that xn follows geometric lambda by n. So our p is lambda by n, so we would have 1 minus lambda by n whole to the power x. All right. Now the next thing is what? Here they are saying yn equal to 1 by n xn. 1 by n xn. Then we have to find where it converges in distribution to. So probability yn less than equal to y equal to probability xn less than equal to ny, y equal to x by n. Okay, from here we are writing it xn less than equal to ny. Now ny, this one we can write it as how? We can write it as equal to 1 minus lambda by n whole to the power this thing, where this means greatest integer less than equal to ny. Because ny could be a like xn can take any values, yn can be only fraction. Okay, until everywhere. So this thing is ny, greatest integer less than equal to ny. All right. So
Yes.
then limit fn, one second. All right. So then limit n tends to infinity f y and y equals to limit n tends to infinity 1 minus lambda by n ny. So this will be 1 minus lambda by n 1 minus limit n y. Okay, so this part 1 minus lambda by n whole to the power n is e to the power minus lambda. Okay, so this one limit n tends to infinity 1 minus p by n whole to the power n, this is equal to e to the power minus p. So from here this limit will be, we had 1 minus limit n tends to infinity 1 minus lambda by n whole to the power n lambda, sorry, ny we had. Okay, so this thing will be 1 minus e to the power minus lambda to the power y. So this will be 1 minus e to the power minus lambda y. So finally what do we have? Finally we have limit n tends to infinity f y and y equal to 1 minus e to the power minus lambda y, which is equal to f y y, where y follows exponential with mean lambda. So then this part is proved that yn converges in distribution to exponential lambda. Any doubt?
It's okay, but I'm not so familiar with many of the theorems in between. That's all.
Okay, so for this limits and limiting distributions, I would urge you to go through real analysis, any book on real analysis. You go through series, sequences, limits. Okay, I can think of Bartley Sherbert at the moment, but because it has a PDF also, Introduction to Real Analysis. Okay, this is the book. It's easily available. You can see my screen, right? Hello?
Yes, ma'am. I'm
Yes.
seeing. I'm
Okay.
seeing the book.
Okay, so I would urge you to get this PDF and go through these three chapters. That it will be very helpful for solving these kinds of things. Series and sequences, limits of function, limit theorems. So far, for this chapter, I think these two are more than sufficient. Chapter
Okay.
3 and chapter 4.
Can we download it or?
Yeah, it's readily available. This is a PDF, right? You can just go to WordPress and get it down. You can download it. Yeah, download option works.
Sure.
All right. So before going to this probability and these kind of things, just go through the theorems. So for example, as I was saying, there is a series proof. So the good part about this is it comes with the proofs. So here if I search series, oh no, you cannot search like this. So anyway, here only whatever series and sequences. This is exercise 2.4 now. So here you would get to know a lot about inequalities and a lot of other things. So whatever I mentioned, that if a series converges, infinite series, if it converges, then the individual sums should individual probability or the constituent elements of that infinite series, that will go to 0. Okay, here there are also a few limit theorems which, one second, I just want to show you that definition. Uniqueness of limits, this is different. I'm just getting logged out. See this one, as I was telling, if b is between 0 and 1, if b is a fraction, then b to the power n will go to 0. Okay, then if a series converges, then its subsequence will also converge. Okay, this one, then this is by definition of limits. Then we have the bounded sequences, convergent sequences. If it is a bounded sequence, then every subsequence will also converge to the same limit, and such kind. So if you can't even understand the proofs, just go through these lemmas and the theorems. It'll be easier to solve such problems. All right. I cannot find this one, whichever I wanted to show you. This is 4.2. So these are subsequences, but before subsequences it was there. See, if you find something like this, it will also go to 0. 1 by n, that will also go to 0.
Yes, ma'am. I have downloaded the book so that
Okay.
I will check.
All right.
Can you please suggest a few books for this probability and statistics where I can follow the few of the contents in the NPTEL?
Uh, you could follow, if you have access to this, first course in probability by Sheldon Ross. This one is also, I think, downloadable. Oh, did did sir mention any references for this course?
Yeah, he has been mentioning multiple books, but
Hmm.
it might be difficult for us to find all the books, right? So I was just
So I think this one, I cannot, it's not loading right now. But I think this is available, first course in probability by Sheldon Ross. You could go through this. For real analysis, you could go through Bartley Sherburne. It is a good book. Or any other probability uh, textbook, basic textbooks at UG level.
okay.
Okay, so you could start with anything. All right, this is not downloading, but I'm sure it has all the chapters. I'm not so sure about the limit theorem part. That I think here you'll get. Hmm. Distributions, estimation part you'll get here more.
Okay.
So so transformation of variables, bivariate cases. This book is also fairly easy to follow. Joint distribution, expectation, conditional expectation, bivariate distribution, how to get that. This is also a good book. You could go
Right.
through this as well. Mood, Grable, and Bose. This is the name of the book. Introduction to Theory of Statistics. Authors are Mood, Grable, and Bose. Looks like this.
Okay.
Alright. This is not loading, but I'm quite sure it has all the required chapters. Alright, just try to fetch these books. These two are readily available. This one,
Okay.
uh, if you can get hold of this, it's good. Google Books should have, no, the contents page. No, it's not showing. But it'll have all probability chapters, limits, theorems.
Okay, ma'am, I will fetch it up.
Okay, okay. Alright, so I'll move on to the next one.
We'll go for one more. We have 20 more minutes, right?
24?
We have a few more minutes to complete the
Yeah,
session,
yeah,
right?
yeah.
We'll go
Yes.
for.
Yeah,
We'll try.
we'll try a few more. That's all. Okay. So here we have xn which follows a normal this thing normal 0 1 by n, mean 0, variance 1 by n. So we have to show that xn converges to 0 in absolute sense. Alright, so absolute sense, what we'll show? We'll show summation n equal to 1 to infinity probability xn greater than equal to epsilon, this exists. This would imply probability xn less than equal to epsilon goes to 0. This will explain this is equal to 0. Alright, for all.
Yes.
Alright, so absolute sense of convergence was this one. Limit xn probability that limit xn equal to x equal to 1. So we'll show this thing. Fine. So now we have to start this thing. Probability xn greater than epsilon equals to, so here xn is a normally distributed random variable. So this modulo of, let's say this is 0 or about 0, modulo xn greater than epsilon, it means xn less than minus epsilon plus xn greater than okay. So this one and this one, this is symmetric about 0. We can write this is 2 probability xn greater than epsilon. So this we can write as 2 1 minus capital phi of epsilon. Capital phi is you can say the cumulative distribution function of a normal random variable.
Okay.
So this one we have. So what do we have? Probability xn greater than epsilon equal to 2 into 1 minus phi of epsilon. Now
Can you show
they have
previous
given
one?
one
Yeah.
this thing expression. So this will be less than equal to 2 by root 2 pi 1 by x. So instead of x we'll write here epsilon. 1 by epsilon e to the power minus x square by 2, epsilon square by 2. No, sorry, here I made a mistake. So phi is a CDF of normal 0 1. Okay, so this will be n phi, n epsilon. Okay, because n xn will follow a normal 0 1.
Okay.
Sorry, root n xn will follow a normal 0, 1. Root n xn will follow a normal 0, 1. This will be root n epsilon. So here we would have n, and here we would have root n. Because xn follows normal 0, 1 by n, root n xn, expectation of root n xn will be 0, and root n xn variance is n into variance of xn, so n by 1 by n, it will be 1. Yes. Alright, so this will be 2 by root 2 pi e to the power minus n epsilon square by 2 by epsilon root n. Okay, so this one we can write as, since
Why that less than or equal to 2 by...
using the inequality.
Okay.
Okay, so 1 by root n, this is always greater than equal to 1, sorry, less than equal to 1. Positive root n I'm considering here. Okay,
Alright.
so even if it is, anyway, this is always less than equal to 1, so this thing we can write less than equal to 2 by root 2 pi epsilon e to the power minus n epsilon square by 2. Okay,
Is that n applicable for the e power n?
no,
Okay.
e power n we don't know what it will be. See, n is always greater than equal to 1. So
Okay.
1 by, when n tends to infinity, so that's what, if n tends to infinity, this thing will tend to 0.
Yes.
Alright, so we have to show that, so the thing about this series is, if summation n converges, then we can imply that an limit n goes to 0, but opposite is not true. If limit n goes to 0 always, we cannot say that summation an converges. Okay,
Mhm.
so here I just cannot say this entire, I have to say this goes to, I mean, this will go to 0 in absolute sense if that summation thingy converges. So here I am going to write this summation, whatever expression we have derived, that I am going to write over here. So what we have is that probability xn greater than epsilon summation n equal to 1 to infinity, this is less than equal to summation n equal to 1 to infinity 1 by root 2 pi 2 by epsilon e to the power minus n epsilon square by 2. Okay, so this one we can write as 1 by root 2 pi 2 by epsilon summation n equal to 1 to infinity e to the power minus n epsilon square by 2. So this thing we can write as 1 by root 2 pi 2 by epsilon summation n equal to 1 to infinity e to the power minus epsilon square by 2 whole to the power n. So let this be some y. Okay, so this is summation y to the power n equal to 1 to infinity. So this will be what? Y by 1 minus y, infinite GP. Okay, so this one we'll write as 1 by root 2 pi 2 by epsilon e to the power minus epsilon square by 2 by 1 minus e to the power minus epsilon square by 2. This is a finite number. This doesn't depend on n.
Okay.
Okay, so this is a finite number. So this implies that xn goes in absolute sense to 0, because we have here xn minus 0. Alright.
Okay.
Okay, so we have to consider a sample space with uniform probability distribution, define a sequence such as this, also define a random variable, show that an converges in absolute sense to x. So absolute shear convergence means limit of x and s should be equal to xs for all s. Okay, so here we'll write limit n tends to infinity x and s is how much? N by n plus 1 s plus 1 minus s whole to the power n, limit. So as n tends to infinity, this part we can write limit n tends to infinity 1 by n plus 1 to s plus 1 minus s whole to the power n. Okay, where s belongs to 0 1, it is saying x belongs to 0 comma 1. Alright, so when x is 0, when s is 0, let's say, then we have x and s is 1, which will go to 1.
How can it be?
Put s equal to 0.
Then the first term,
So
1 by
x and
1 by n,
0
that becomes
will
0,
be
right?
0,
Mm-hmm.
n by n plus 1 into 0 plus 1 minus 0 to the power n. This will be 1 to the power n, it is 1.
Yes.
Okay, x and 0 is 1. So this one, let me write excluding 0, open bracket 0. Alright, open bracket 0 1. Whenever it falls between open bracket 0 1, then this one, as n tends to infinity, 1 by n goes to 0. This part is s, and since s is a fraction between 0 and 1, this thing to the power n will also go to 0 as n tends to infinity. So this will be s. You understood?
Yes, I'm getting.
Okay, so when s belongs to 0 and 1, all right, when xn is 0, then limit x and s will go to 1, sorry, 0.
Yes.
sorry, it will go to 1.
It goes
1 or 0 it goes to
zero, right?
xn 0 is n by n plus 1 into 0 plus 1 minus 0 whole to the power n. It goes to 1.
Okay.
Okay, and x0 is how much? 0. xs equal to s. Okay, and xn1 is how much? N by n plus 1 into 1 plus 1 minus 1 to the power n. That is n by n plus 1, 1 by 1 by n plus 1, which goes to 1. And x1 is also 1. Okay, so this thing we have to be very careful while writing. Xn limit n tends to infinity xn x equal to xs for all s belonging to 0 comma 1. Okay, now since we can say that probability 0 comma 1, this is equal to 1, therefore xns converges absolute surely to xs.
All right.
Alright, because the absolute sure definition is this: probability limit xn equal to x equal to 1. Alright, we got this?
Yes.
Fine. So we'll move on to the next one. Alright, so xn and yn be two sequences of random variables defined on this random space. Suppose that we know xn absolutely converges to x and yn absolutely converges to y. Then xn plus yn absolutely converges to x plus y. Okay, so let us define sets such that limit n tends to infinity xn s equal to xs. Okay, similarly let us define b s belonging to s limit n tends to infinity yn s equal to ys. Now
Is this mean they are independent in each other, or
nothing has been said.
okay?
Okay, so by definition of absolute sure convergence, we have probability of a equal to 1 and probability of b equal to 1. Okay, now we will find probability a intersection b. This is equal to one minus probability of A complement union B complement. This is fine?
Yes.
Okay. So this thing is greater than equal to 1 minus probability of A complement minus probability of B complement. Is this okay?
How the
Because probability P union Q equal to probability P plus probability Q minus probability of P intersection Q. So this is always less than probability P plus probability Q.
okay.
Okay. So here we are using greater than equal to this thing. So here probability A complement was, so probability A by absolute sheer definition was 1. So A complement was 0, this is 0. So probability A intersection B will be greater than equal to 1, which implies probability A intersection B is 1. Okay. So
Yes.
let us define set C such that limit n tends to infinity Zn s equal to xs plus ys. Alright.
Yeah.
Now we will claim that A intersection B is a subset of C. Okay. Now if S belongs to A intersection B, it implies S belongs to A and S belongs to B. So from here we have limit n tends to infinity x and s equal to xs, and from here we have limit n tends to infinity y and s equal to ys. Okay. Then limit n tends to infinity z and s equals to limit n tends to infinity x and s plus y and s, which is equal to limit n tends to infinity x and s plus limit n tends to infinity y and s, which is equal to xs plus ys. Then what do we have? We had x belonging to A intersection B. Okay. And x belonging to C. Because C was this set, that S, this limit will be equal to xs plus ys. So S also satisfied here. So we started from here, we landed up here. Okay. So which implies that A intersection B is a subset of C. Therefore, probability C is greater than equal to probability A intersection B, which is equal to 1, which implies probability of C is also equal to 1, which implies that Zn converges absolute surely to x plus y.
Okay.
Okay. Fine. So now we'll solve the next one. Suppose xn and yn are two sequences of random variables defined on sample space S. Suppose we know that xn follows in probability to x, yn follows goes to y in probability, then xn plus yn goes to x plus y in probability. Okay, so similarly also we will define sets over here. So A will be, an is xn minus x less than epsilon by 2, bn is yn minus y less than epsilon by 2. Okay, so here we have, for all epsilon greater than 0, since they converge in probability, limit of probability of an is 1 and limit of probability of bn is 1. Alright, so then limit of probability, so now we'll again take that intersection thingy. So what we'll do, we'll write probability an intersection bn equal to probability an plus probability bn minus probability an union bn.
Okay.
Okay, so this is greater than or equal to probability an plus probability bn minus 1, since probability an union bn will always be less than or equal to 1.
Yes.
Okay, therefore limit this one will be, 1 second, probability an we had 1, bn also we had 1, so this will be 1.
Okay.
So now limit of n tends to infinity probability an union bn, intersection bn, this will also be equal to 1.
Yes.
Alright, now we'll define C. Cn we'll define in this manner. So Cn will be xn minus x plus yn minus y less than epsilon. Also we'll define dn, xn plus yn minus x minus y.
Why the absolutes are different into C and D? Xn minus x. Ma'am, the 48th slide. Ma'am, the 48th slide.
48th slide, no?
Xn minus x absolute plus absolute of yn minus y. Why we define that particularly?
In order to define the triangle inequality that is downstream.
Alright.
So this is just how we have to solve this problem.
Okay.
Alright, so I think this is better in some other way.
Mhm. What is the mode xn plus yn minus x? Is it the same thing or is that different? C and D.
See this one, if you remember the triangle inequality,
Mm-hmm.
what was this? A plus B less than equal to A plus B, or greater than equal to, what was it? I forgot. A plus B less than equal to mod A plus mod B. Huh. Uh,
Ma'am, are you there?
yes, yes, I'm there. I'm just thinking. Uh, so C and D we have defined. Then what do we have to show? Mm, 1 second.
We have proved a limit infinity A intersection B is equal to 1. So something related to that with C and D.
Yes, something exactly that only we'll go. So, okay, we were here. Probability A intersection Bn equal to 1.
Yes.
All
And
right.
C and D are the elements of something related to A and
Okay,
B.
so we have to show that Cn is a subset of Dn, which would imply that probability of Cn is less than equal to probability of Dn. Now, if we can show that probability of Cn is equal to 1, then we can automatically show that this is also equal to 1, then that probability convergence holds.
Can you please repeat the last two sentences? When Cn
So if Cn goes
convert.
to 1, if this probability is 1, then probability Dn will also be 1,
Yes, yes.
and Dn is that x plus y equal to, so xn plus yn goes in probability to x plus y. This expression is captured by this set.
Yeah, okay.
Okay,
Oh,
so we
uh-huh.
have to show that probability of Cn is equal to y, 1.
1.
Alright, so now we have to go from A intersection B to Cn. So how are we going to do that? Alright,
Xn plus Yn is equal to 1. So, is that
so we have An intersection Bn is what? An is what? An is such that xn minus x is less than epsilon by 2. Bn is what? Is such that xn minus yn minus y less than epsilon by 2. Okay, and so Cn, and Cn was what? Xn minus x plus yn minus y less than epsilon. So from here we can say An plus Bn is a subset of Cn.
How can it? Yes, 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 yes,
We can say this thing. Okay.
yes.
So if this is holding, then it implies probability An plus Bn is less than
Is
equal to probability of Cn.
is equal to 1.
Okay.
Yeah.
So this one is also equal to 1 in limiting sense. So it
Yes.
implies probability Cn equal to 1.
Mm.
So then we have probability of, and also Cn is a subset of
Dn.
Dn because xn plus x plus yn minus
Plus
y is greater than equal to xn plus yn minus x minus y. So therefore we have An intersection Bn subset of Cn subset of Dn. So probability of An intersection Bn less than equal to probability of Cn less than equal to probability of Dn.
Dn.
And this one is equal to 1 that we have obtained. Limit n tends to infinity, probability An probability Dn is greater than equal to limit n tends to infinity, probability of An intersection Bn, which is equal to 1.
Yes.
So then this limiting probability is, since it is 1, therefore xn plus yn goes in probability to x plus y.
Okay. Okay, got it.
Okay.
Yes.
All right. So next week I am going to come with more such problems on limits because I believe that there were a lot of queries today. So
Yeah.
I will come with few more problems and we'll solve that in class in order to make this chapter a little more clear.
Okay. Can we see this your notes in the NPTEL, or how can?
Yes, you can. So here, if you go to your NPTEL thing, here you'll have this problem solving recordings and the links to the PPTs. All of
Okay.
these will be available. You can just go and check.
Okay. Can we see the notes of the Professor Dharmaraja? The PP.
Notes, I don't think it's
Yeah.
available. You can download the videos.
Yeah, I'm studying with the videos and transcript, but I was trying to see if I can have the
I
notes.
don't think there is any notes over here.
Thank you so much, ma'am. It is really helpful to me.
Thank you for joining. And if you do have any questions, let me know. If you by the time by next week, I hopefully this deadline will be over. So maybe I can solve the assignment questions if not anything else. I'll try to
That's
do
okay.
that.
You have given me some theory how to approach it, right? So I will also make it how we can
Okay. You
how we can
try
do
these
that.
things, and if it still there is some doubt, uh, just tell me the next week. I'll try to solve that.
Okay, next class will be this. If it is Saturday, it would be helpful for me.
Yeah, it
Otherwise, it
is
is.
every Saturday there's a class from 3 to
Uh-huh.
5. You
I
can
think some of the classes were postponed to Monday and all.
actually
And
there are 3 sessions, one on
uh-huh.
Friday, one on Saturday, and one on Monday. So you could join
Okay.
any one to get the doubts clear. These are like
Okay.
parallel sessions.
All right.
All
Thank
right.
you. Thank
Okay.
you.
Thank you
Bye.
so much for joining. I'll see you next week. Bye bye.